Hello, my dear student. I'm Sakitwala from Educators. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our revision exercise for our topic of rotation of rigid body in our subtopic of the moment of inertia as we observe here. So, my dear student, before we proceed with our discussion here, we are supposed to remember where we ended on the last session. On the last session, we tried to see how can we derive the moment of inertia for a ring. Imagine that we have the ring and that ring we tried to rotate on its axis. Now, how can we get the moment of inertia? We tried to derive and obtain that a moment of inertia for a ring must be equal to mr squared divided by 2. That is what we obtained. So on our today's discussion here, we are going to see the examples related with the moment of inertia for a ring that is rotating on an axis. As we observe here, an example say that if a flywheel of a mass 30 kilogram and a diameter of 1 meter is rotating at 300 revolution per minute about an axis through its center. What is the kinetic energy of the flywheel? This is the needs of our question. That imagine we have the flywheel, and that flywheel contains the mass of 30 kilogram. Try to rotate on an axis and form the frequency which is equal to 30 revolution per minute as we observe here. But the ring involve the flywheel involve the diameter of 1 meter, and this diameter should give us the radius. It means that we obtain the radius using the relationship with its diameter, and we say that always the radius or the distance of the flywheel must be equals to the diameter divided by 2. That is what we are going to see here. So before we proceed with our discussion here, we are supposed to summarize our given values here. And we observe that for our question, we have the mass of the flywheel, which is equal to 30. Now we can summarize that the data given must be equals, the data given is like 1, we have the mass of the flywheel, which is equal to 30 kilogram. And also we have the frequency, which is equal to 300 revolution per minute. And we were supposed to convert this revolution, this frequency into the second. As we know that the unit of the frequency is revolution per second, or sometimes we rate as the hertz. Sauti yake inakuwa ni hertz. This is how we can experience it. So now we are supposed to convert this frequency into this frequency into the minutes, and we say that we should take the 300 revolution per minute and divide it by 60 seconds, and after dividing we should obtain that the frequency must be equals to 5 revolution per second, or is equal to 5 hertz. That is what we should write after summarizing our given values. But the radius must be equals to the diameter divided by 2. Imagine we have our diameter which is equal to 1. Now we should divide that diameter over 2 and obtain that diameter must be equals to 0.5. That is what we are supposed to try to write. So how can we find this equation? So we find this equation, my dear student, how can we obtain the kinetic energy? And we know that the kinetic energy should be obtained using the equation number 15, as we try to derive on the past sessions, and also the equation number 29 on our first topic here. That is how we can demonstrate the kinetic energy. So on the equation number 4.15 here, we tried to demonstrate the formula of the kinetic energy, and we said that always the kinetic energy must be equal to half the times the moment of inertia, then we multiply it by the angular momentum square, or the angular velocity square. But the question number 29 here, we said we tried to look at the relationship between the kinetic energy and also the moment of inertia for the fly disk here. Now, what we can do here, the thing that we are going to do, we should remember the formula of obtaining the kinetic energy. And we say that kinetic energy must be equals to half times the angular times the moment of inertia, then we times it by the angular velocity. But the moment of inertia for the moment of inertia is obtained by taking a half times mr square, where m represents the mass of the flywheel here, and the r represents the radius of the flywheel, my dear student. Now we should take that moment of inertia and substitute it into our formula here. If we substitute, we should obtain that kinetic energy must be equals to a half a bracket times a half mr square, then we times it by the angular velocity square, that as we observe is out of this one. And after there, we are supposed to change that angular velocity. We are supposed to change that angular velocity in terms of the frequency. And we know that the angular velocity must be equals to the ratio of the angular displacement, then we divide it by time. But in terms of the period, we say that angular momentum must be equals to 2 pi divided by time. But in respect to the frequency that we have been given here, we should write that angular velocity must be equal to 2 pi f. Now we should substitute, instead of writing the angular velocity square, we should substitute equals to 2 pi f as we observe here, 2 pi f square. And finally here, we should say that kinetic energy must be equals to a half times a half mr square, where m represent the mass of the flywheel, and the r square represent the radius of the flywheel. And also this f here represent the frequency of the flywheel when it is trying to rotate about an axis, as we tried to observe on the past session. And after this, my dear student, we should take the value that we have on our question and put it into our formula here. Now we are supposed to go and paste our data that we have been given into our question. As we see that in terms of writing mass, now we are supposed to take the value of mass and substitute, which is equal to 30 kilogram. And also the radius here. We should substitute the formula, the value of the radius, which is equal to 0.5, which is obtained after taking the diameter, then divided by 2. Now we obtained it at 0.5 square. Now we times the 4 pi square. We have we tried to times it by the 4 pi square. Then we multiply it by this frequency. This frequency, as I said, that this must be obtained by taking the frequency. And after taking the frequency here, which is 30, is in terms of revolution per minute. But the unity of the frequency should stay in revolution per second. Now we should take this 300 and divide it by 60 seconds. And after there, after substituting our given value here, now we are supposed to take our mathematical calculator, my dear student, and take these values and paste it into our calculator. And after that, we should obtain this kinetic energy, which is equal to 1850.6 joule. This must be the value of the kinetic energy, which is obtained either by using our heads or by using our mathematical calculators. I know that all students who taken science in advance, we have our mathematical calculator. Now we should use those mathematical calculator and obtain our value here. So after this one, now we are supposed to conclude by saying that therefore the kinetic energy of the flywheel about an axis through its center must be equals to 1850.6 joule. This must be the kinetic energy where where the flywheel tried to rotate about an axis through the center. It consumed 1850.6 when it was still in motion. So, my dear student, now let us go and proceed with another terms here.